Okay, so we're going to look at an alternative way to create a chamfer. So this is again the bushing plate part where I have removed the chamfer before I've imported as a DXF. Okay, so I've set my block, my billet and my thickness. So first thing I'm going to do then is I'm going to machine the outside edge. Okay, so I'm going to select my tool. I'm going to just pick this flat 16 mil. Okay, tool direction. So I want it to be outside of this line. Okay, and then rough or finish. So levels and cuts. Safe rapid down to 50, down to 2, material top 0, and I think it was minus 16. This one, so go for that. Okay, stock to be left 0. I'm just going to do it all in one. Number of cuts. Do it in 4. Lead in, lead out, apply. Okay. And I'm going to pick the line coming in approach angle at 45 degrees. Yeah. I'll pick this line. Okay. So if I just simulate that. So you can see in previous examples we had set our initial stock. So if I just go back in and edit this, we'd set our initial stock here as a figure. So in that case, that meant that we were cutting fresh air in some cases. So we've went with 0 here and it seems to have worked. So that's good. Okay. So to create the chamfer in this alternative way, we need to be able to lock our previous tool path. Okay. So because we are applying, so if I look at this in top view, we will be applying a tool direction to this line, and it already has a tool direction applied based on this machine in operation where we've profiled the outside edge. We now want to put a chamfer on this edge, but if I leave this unlocked and then go select my chamfer tool direction, I want it to cut on center. But by doing that, then this will change to cut on center. So there's a couple of wee buttons up here. Okay, so one of which is lock. Okay, unlock all toolpaths. So lock. So once you lock it, basically it's very, very hard to go back. So you need to be very sure that it is correct up until that point before you apply your chamfer, that you have simulated all your operations and you're sure that they're right and you're happy with them. So I'm going to click this lock button. Okay, so you can see now a wee lock has appeared on those two toolpaths. Okay. So now I'm going to select my tool. So engraving, I'm going to pick 10 mil by 45 degrees. You can see here, there. So pick that. So tool direction, I'm going to be clockwise and on center. So I'm picking this line. Okay, so you can now see it's on center. Okay. And then rough or finish. So okay, so we're going to go down 2 mil. So if it's a 2 mil chamfer, in the previous cases we went down an extra mil. In this case, we're just going to go down -2. Number of cuts should be 1. We want to leave 0 stock and apply lead in, lead out. So leave that as a line. Okay, I'm going to pick that. Okay, so if I now go to simulate that. Okay, so just run that again. Okay, so you can see here where we have went in and we're chamfering. Okay, So the reason that you could do this other method of chamfering is, rather than using the offset line, is if you have a part which has lots of features and there are lots of lines. So if I turn this off and just have a look. So on this case, there isn't lots of lines here. Okay, so if I offset that, I can easily see which is my new offset line. But if you had a lot of different features, like if you were chamfering on the inside of a pocket and it had multiple, like a hole going right through, and you had maybe several, 3 or 4 different pockets going down different depths, you have lots of different lines and it can become confusing then as to which one actually is the right line to pick. The only thing with this method is you have to lock all your previous tool paths to be able to pick on center. And once you lock them, it's very, very difficult to go back. So if you wanted to go back and change something, it's really not possible or very, very difficult to do. So that's why you need to be sure that before you do this, that it's correct, because it's very, very hard to undo then. Okay, so that's just another way of chamfering.